Morning, everyone. Today, I guess this week's videos, gonna have a few different things. The first thing is we're gonna talk about inverse trig functions. Then we're going to be solving right triangles and doing some word problems in this first video. Second video, we're going to be doing these things called trig identities, where we've already kind of talked about them already, but we're going to be kind of solving some equations. Just using some properties of trig values. So let's jump right in so we don't waste too much time. Inverse trig functions. I wanted to introduce you just to these graphs and kind of give you a brief rundown about what they are. So last week we did all the trig functions. We did graphs of sine, cosine, tangent, cosecant, secant, and cotangent. Now there are three more graphs, and they are the arc sine, the arc cosine, and the arc tangent, or the inverse sine, inverse cosine, inverse tangent. So I have the graphs here. If you want to jot them down, you can. But I just want to talk to you a little bit about them. Maybe my computer froze, maybe it didn't. Who knows? Let's see. Hey, all right, there we go. Cool. So the first one we have is arc sine. I could always say arc sine, sine to the -1, the inverse sine like that, and arc sine mean exactly the same thing. So if you're on your calculator, it's second sine or second cosine, second tangent. It's over there. You can graph those. This is the graph you're going to get on the calculator. All right. The reason I want to show you these is because in calculus, you're not going to have to graph them. The more important thing with them is usually the range and the domain possibilities. All right, so here are your graphs, and there's going to be a few things. One thing I always want to point out with these is that your x value, all right, whatever's in parentheses, is going to be a value for an angle, okay, which is your y. The y is your angle, and it's always going to be in radians. All right. So let's talk about the domain and range, just based on these graphs. So let's do arc sine, arc cosine, and arc tangent. I'm going to put an x here too because it has to be of something. All right. So the domain and the range. Okay, so the domain, just take a look at the graph, right? Possible x values for the arc sine. Right? If you look at arc sine, the x values are really just ranging from -1 to 1. So what we would say is from -1 to 1. Now our range, well, that's the y value. Lowest point is -π/2. Highest point is π/2. Cool. Our cosine, then I'm going to scroll down a little. That's this one here to the left of the chart. Your domain is still -1 to 1. But your range is a little different. The range is 0 to pi actually. Remember, square brackets, you can include it. And then arctan, it's the one I have up here above the chart. See, your domain for arctangent is really all real numbers if you take a look at it. The other way you could do it is you could also say -infinity to infinity. Oh, those should have parentheses because remember you can never equal infinity. But your range, right, your range is between π/2 and -π/2. But notice we have horizontal asymptotes there, so you can't equal those. But basically, what you're going to need to know for calculus is this domain and range part, which is the reason why I wanted to show it to you. Because if you were to type stuff into your calculator, and sometimes it'll give you a negative answer, and you'll be like, but wait, I know that's not right. Maybe you've already done this, but, like when you've been doing some homework. But if I wanted to know, well, if I did like the arctangent of negative square root 3, well, that's negative 60 degrees, because I'm in radians, right? I'm in degrees right now. So mode, let's go to radian. And it technically should give me negative pi over 3, which is that. So pi divided by 3, which is still negative. So if I'm giving me the negative 1.047, it's still the same thing. But we wouldn't say it's negative 3, we wouldn't say it's 300 degrees for our answer. We would say it's negative 60 or negative pi over 3 because of the range where it falls. Okay, since we're dealing with tangent, we would be following that range. Okay, that's really the only spot you're going to kind of use it in calculus, which is why I wanted to introduce it to you. But then we're going to use it to solve triangles. All right. So if we have missing sides, we need to use the inverse sine, the inverse cosine, inverse tangent to find those missing angles. And then we're going to do some word problems. No, don't need to do that. Okay. All right, solving right triangles. So you're going to be given some certain information, right? All right triangles are going to have the following setup, right? You can have little a, little b, little c, big A, big B, and big C, right? Angle C is always equal to 90 degrees, okay? This is bringing it back to geometry. So you're going to start's going to always be our starting point, and then we go from there and we solve everything. So when you're solving right triangles, you want all sides and angles, right? So let's say you're given angle A is 20 degrees and side B is 15. So we can make our right triangle. I forget, I can just draw one. Always have 90 degrees. So angle A is 20. So I'm going to put 20 down here. So that means this is side A, this is side C, this is angle B, okay? And this means this side's little b. And if we know b is 15, what I want to know now is, well, I know big A is 20. I need to figure out big B, and it's going to be something degrees. Angle C, if you want to put down it's 90 degrees, you can. It's always going to be 90. But I need to know little a, so side A. Side B, we already know is 15. Side C, I want to know that as well. So the first thing I would probably start with is the easy one. I would probably find angle B, because if I know angle A is 20 and angle C is 90, that means angle B is 70 degrees. Let me put it in different colors so we can kind of see the differences, what we are actually finding. All right. So I did that again just by doing 180 minus 90 minus 20, and you get 70. So now we got to pick a side to find. Let's see if we can figure out side A. One thing I want to point out is that you usually want to use the angles that are given to you. So even though I just found 70, I don't really want to use that in any of my math to figure out side A or side C. You want to use the one that's given to you in the problem, because sometimes this angle isn't going to be that nice. So based on that 20 degrees, if I want to know side A and I know side B, I want to know the opposite and I know the adjacent. So then I pick either sine, cosine, or tangent based on SOHCAHTOA, and I use that trig function. So if I need to know the opposite and I know the adjacent, that means I have to use tangent. So tangent of 20 degrees is opposite side A over my adjacent 15. Now when you're doing this, be sure that you are in not radians, in degrees, because we are in degrees right now. So I'm going to have to change my calculator back to degrees before I start doing some math. So then I can go back to my equation, and if I need to solve for just little a, I need to multiply both sides by 15. So I get 15 tangent of 20 degrees equals a. Grab my calculator, 15 times tangent of 20. There it is. So 5.459, blah, 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 blah. Let's just go with 5.5, right? Seems okay. Okay. Now once you have two missing sides, you can find that third side using, again, either a trig function or Pythagorean theorem, because this is a right triangle. All of these are right triangles. So I can do 5.5 squared plus 15 squared equals c squared. So 5.5 squared plus 15 squared looks like 255 1/4. Square root of 255 1/4. Yep, looks like we can round that up to 16. Because anywhere, if I try to round any of those things, it rounds like everything up. So let's just go with 16. So this would be your answer. You give me all sides and all the angles if it's saying to solve the triangle. All right, let's do one more of those. Then we're going to jump into some word problems, because that's when you can actually apply these things. Let's say side A is 52, side B is 16. So I'm not giving you any angles, except, well, you technically know angle C. But let's draw the triangle. Oh, looks like I'm making it longer. Okay. A, B, C, C, A, B. Okay. So I'm going to label what we know. We know A is 52. We know B is 16. But I want to know big, so angle A, angle B, angle C. Side A we know is 52. Side B we know is 16. Side C we do not know, but we're going to find very shortly. So again, right now, that's our given information. We know that stuff. So let's find side C. So we're going to do a squared plus b squared equals c squared. So I get 52 squared plus 16 squared equals c squared. And I grab the calculator. So looks like I get 54.4. There's no units here, so we just kind of leave it the way it is. So now we need to figure out angle A and angle B. But really, once you find one angle, you can find the other one just by subtracting from 180. So based on given information, remember, we don't want to have to use this side C. We just want to use the given information. We can find either angle A or angle B. But let's go with A because it's alphabetical order. So to figure out angle A here, I know the opposite side and I know the adjacent side. So opposite and adjacent goes with tangents. That means the tangent of angle A is 52 over 16. This is where the inverse trig function comes into play. What we need to do is we need to use the arctan, or the inverse tan, of 52 over 16, and that's going to give me my angle. So I'm going to grab the calculator, move it over out of the way so we can actually use it and see what's going on. I'm going to hit second tan 52 divided by 16. And I get 72.897. How about just 72.9? Alright, so 72.9. Let's make a fancy 7. Look at that. You know, that's a fancy 7. Only like cool people make 7s with that little like thing coming down and you cross it. Oh yeah. Alright, angle B. I'm just going to do 180 minus 90 minus 72.9. 17.1. Nope, gotta make my fancy 7. So there we go. That'd be solving your triangle. All right. So the next one I want to do is a word problem, and it's actually in your book. It's on page 359. I also have the picture of it here. But we're going to do a word problem from the book because some of your homework is based on that. And what we're going to take a look at is actually number 15. All right, I'm going to have to scroll. Actually, I don't have to scroll. Look at that, because it's, maybe see if I can zoom in for you. All right, so here's 15. So 15 saying the sun is 25 degrees above the horizon. Find the length of the shadow cast by the silo that is 50 feet tall. So if you look carefully, you can see a right triangle. Okay. And if you have the right triangle, I'm going to recreate this right triangle in my notebook. So I'm going to go back to my notebook, get myself a nice clean page. This is on page 359, number 15. So I'm going to make a right triangle. Whoa. Well, I guess that works. And then connect it. And we had 25 degrees in the bottom left and 50 feet on the other. So 25 degrees and 50 feet. And it wants to know the length of the shadow. So all we're going to do is either use sine, cosine, or tangent and see if we can figure out this missing side. Well, based on the angle 25 degrees, we know the opposite. We want to know the adjacent. And that's tangent. So the tangent of 25 degrees is our opposite over adjacent. I don't know. I'm going to put x. Why? Because that's usually what we use in math. Doesn't have to be x. It can be any variable you want. So now we just got to solve for the variable. So when we solve, we really get x tangent 25 degrees equals 50. So x is 50 over the tangent 25 degrees. Grab your calculator, you plug it in. 50 divided by the tangent of 25, and we get 107.22. Well, how about 107.23? So x is 107.23, and since we have units here, I'm going to say feet. So that's the length of the shadow cast by the silo. And we'd be all set. Cool. Cool. Shoot it, bam, bam, bam. I don't know where I got that question. My next question, my notes, I have no idea where it came from. But let's see if it's actually this one. Yeah, definitely not that one. See, I have it number 5, and it's definitely not number 5 here. But that's okay. All right, let's do, let's go to the next page, see what we got here. So we have a ship. Let's look at 31. See if we can just do part of 31. It says a ship leaves port at noon and has a bearing of south 29 degrees west, and the ship sails at 20 knots. You don't need to know what a knot is. It doesn't matter. How many nautical miles south and how many nautical miles west will the ship have traveled at 6 p.m.? Well, it leaves at noon and is traveling 6 p.m. All right, so what that means, well, let's first draw this triangle because we're going to get a triangle based on that. All right. So what I actually like to do is put like a little dot, because here's our boat. All right, and on our boat, we have a compass. We have north, south, east, and west. Okay, and it said it was sailing. I think what was it, south 29 degrees west. So really the way you approach that, so south 29 degrees west, is you're going to go south first and then go west 29 degrees. Okay, so if you kind of look, you are going to start to make a triangle. So that means this angle up here is 29 degrees. So this is the starting point. This is the ending point. All right. Now it wants to know, well, we actually could know how far it traveled. And the way we can know how far it traveled, which would end up being the hypotenuse here, is because it started at noon. And it ended, ugh, my handwriting's horrible, at 6 p.m. So we know we traveled 6 hours and had a speed, I don't remember how fast we were going, 20 knots. So that means this whole side is going to be our 6 times 20 knots, and that's going to be our nautical miles. That's 120, it's this missing side. And the question's asking, how far west and how far south has it traveled? Well, how far south is this side? How far west is that side? So we are basically given an angle and a hypotenuse. And now we need to find the missing sides. So again, I think this is number 31. We're just doing part A, 31. So based on that, let's find how far west. All right, we need to know the opposite. We know the hypotenuse. So we got to think opposite over hypotenuse. Opposite over hypotenuse is the sine. So it's sine of 29 degrees is your opposite west over 120, our hypotenuse. So that means our west is equal to 120 times the sine of 29 degrees. And we grab a calculator and we plug it in. And we get 58.2 miles west. So 58.2 miles. So that's the west part. Then to figure out how far south, well, I gotta find that side. And again, everything's based off the 29 degree angle. So now I need to know the adjacent and hypotenuse. So which one has adjacent over hypotenuse? That's cosine. So south over 120. So you get 120 times the cosine, 29 degrees is how far south. We get 104 point, actually we can just round it up to 105, huh? So that would be our answer for how far south. These bearing types of questions, if we were to do this in school, we would actually spend a decent amount of time on them, because I kind of enjoy them. They kind of give you some, well, a lot of word problems deal with them, the bearings with the boats and the planes and stuff like that. But they can get confusing. The one thing I do want to point out is to try to make a dot, a starting point and ending point, and put your compasses on those points, so that way you can kind of visualize where your right triangle is going to be drawn. So yeah, I think this is going to be the end of this video.